Okay, so Chapter 8, Periodic Properties of the Elements. You should read Section 8.1, but I'm not going to cover it. 8.2, about the periodic table. Some of this we've already talked about, but Mendeleev, back in the 1800s, there were not a lot of elements known initially. And as more and more elements were discovered, people were looking for ways to organize them. So he ordered the elements by atomic mass and saw these repeating properties. And so we talked about his periodic law, that when elements are arranged in order of increasing atomic mass, certain properties recur periodically. And he used these patterns to predict properties of undiscovered elements. So when the atomic mass order didn't fit other properties, he followed the other properties and left a gap and said, there's got to be something else in there. And then sometimes, like with tellurium and iodine, if you look at them on the periodic table, tellurium has a mass of 127 point, is that 8 or 6? Doesn't really matter. And iodine is 126, which is less. So the order by mass would have predicted iodine first and then tellurium, but that didn't match up with other properties, and so he swapped those and went by properties, because iodine behaves more like bromine than like selenium. Here are two of his predictions. He predicted that there would be an element found below aluminum, and it was discovered later. It is gallium. He predicted its atomic mass would be about 68 atomic mass units, and the actual one was 69.72. He predicted a low melting point. Its melting point is 29.8. Here you see the picture of gallium in someone's hand. It will actually melt in your hand. It's a solid at room temperature, but its melting point is so low that if you hold it in your hand, it will melt. Kind of like chocolate, but it's a metal. Craziness. Density, he nailed it. Formula of the oxide, nailed it. Formula of the chloride, got that right as well. He predicted ecosilicon, meaning below silicon, that there would be another element. That was discovered later, and it was germanium. His predictions of atomic mass, density, formula of oxide, formula of chloride, all very, very close. Amazing. Absolutely amazing. Predictive properties of these patterns, these repeating patterns. How did he do this? He looked at the densities and the melting points of the elements around them and looked at trends and decided that this would fit in the trend and predicted, and was very successful in that. So Mendeleev's law allows us to predict the properties. It allows us to predict what happens, but it doesn't explain why the patterns exist. Quantum mechanics explains why the patterns exist. And when we know why, then we can predict what. So knowing why is actually the ultimate thing.